Welcome to PK's classes. Today we will discuss about the mechanism of action of macrolide antibiotics, and this is the structure of the macrolides, and we can classify them structure as macrolides and ketolides. Erythromycin is an example of ketolide. Then you can see the structures: erythromycin, telithromycin, solithromycin. Solithromycin is an example of ketolides. And the ring can be 15-membered ring or 14-membered, or 14, 15 or 16-membered ring, and also can be natural or semi-synthetic. Accordingly, we can classify them, the aminoglycoside antibiotics: natural, semi-synthetic, 14-membered ring, 15-membered ring, 16-membered ring. So it starts with 12-membered ring. So 12-membered ring, or 14-membered ring, or 15-membered ring, or 16-membered ring. Also, we can classify them generation-wise. First in generation, which are mostly natural products: 12-membered methimycin, 14-membered picromycin, erythromycin, oleandromycin, loncamycin, 16-membered carbomycin, nidamycin, tylosin. Then second generation onwards, they are semi-synthetic. Second generation 14-membered macrolides like clarithromycin, roxithromycin, flurithromycin, dyrithromycin. 15-membered macrolides, azithromycin, the most commonly used macrolide antibiotic. Then 16-membered macrolides like miocamycin, rokitamycin, tilmicocin. Then the third generation, mostly they are the ketolides: 14-membered, telithromycin, solithromycin, zithromycin. So in this way we can classify structure wise, ring wise, and this is another one, the 16-membered, 17-membered ring also there, and natural, semi-synthetic, and generation wise. Now let us discuss the mechanism of action of the macrolide antibiotics. So macrolide antibiotics bind to the 50th subunit of ribosomes. 50th subunit of ribosome. So we know in the prokaryotes, or bacteria, there is two subunits, 30th subunit and 50th subunit. And the 50th subunit has three sites: A site, then P site, and then finally there is the E site. E site or exit site. So tRNA, transfer RNA with amino acid. So this is the tRNA, where this is the amino acid, and so you can refer to our earlier classes on protein synthesis to be clear about how protein synthesis occurs. So the messenger RNA binds to the 30th subunit, whereas tRNA, transfer RNA, binds to the 50th subunit. So initially it binds to the A site, then it goes to the P site. So in A site, this messenger RNA has codon. These codons are recognized by the anticodon. So this codon represents one amino acid, and that transfer RNA carrying that amino acid has the anticodon for this messenger RNA. So there will be pairing of codon and anticodon, and then it moves to the next one. So next tRNA comes, and here suppose this is the P site, so in the P site, so it will be in the P site, let us, so in the P site the tRNA, suppose this is the first one, and accordingly one after another this goes to the E site and the next comes, then it joins here. So accordingly the chain elongation occurs and we get the protein. So the macrolide antibiotics, they inhibit the protein synthesis by binding to the larger subunit, that is the 50th subunit, and this 50th subunit consists of 2 ribosomal RNA, rRNA, 5S and 23S, and there are 31 proteins. So this 23S subunit is the target of the macrolide antibiotics. So macrolide antibiotics bind to the 23S ribosomal RNA, and to be particular, so the A2058 of adenine base number 2058 of 23S ribosomal RNA. In E. coli there are 2904 this number of nucleotides. So E. coli, Escherichia coli is 2904 base long, nucleotide long, and in that the 2058, the adenine, to this site these macrolides they bind, and because of this they what is the function of this binding? This is essential for binding of peptidyl tRNA with the ribosomal P site. So that tRNA binding is inhibited and hence the protein synthesis is inhibited. So you can write here, macrolides bind to the nucleobase of A2058 of 23S ribosomal RNA, component of 50S subunit of bacterial ribosome, and inhibit the binding of peptidyl tRNA in the ribosomal P site and inhibit the protein synthesis. Thank you.